This is the assignment I gave last week. And almost everybody's turned it. I think there's only one person in this class that has not turned this in yet. One person. And they're not in here right now. They're absent today. Maybe they'll make it in here. Maybe not. But I want to talk about this problem that I gave everyone last week just to get you thinking mathematically. It's nothing that we studied, but it's stuff that you should already have some idea about. So I gave you this problem last week, and I said, okay. I said A, B, and C are all integers, right? So I said A, B, and C are all integers. So if we have the equation where A times B plus C equals B plus A times C, and it says equals, so the left side must be equal to the right side, what limitations are there at A, B, and C? And then I gave you just some things to think about. Can A, B, and C all be any number? Will this be true? Is there only one number that A can be for this to be true? Is there only one number that B or C can be for this true? What are the possible numbers that would make this equation true? So that's the assignment you had last week. And if you didn't turn it in, then you already have a 0 in the class. I'd go turn it in right away before tomorrow's grade checks, because right now your grade's a 0. Everybody should have a grade in this class, either 100% or 0. Because, oh yeah, so here's the good thing. Here's the great thing about this assignment. Like I said, you have 100% or you have a 0. There's no in between, because I didn't grade this to say, let me see what you said about it. No, that's wrong. I didn't do that. I said, did you do it? Okay, you gave me an answer, 100%. Without even looking at your answer, I said 100%. Then I went back and I've looked at the answers since then just to see what everyone's turning in. So you either got 100% or you got a 0. And the only reason you got a 0 is because you never did it. So easiest assignment you're going to have all year. I'll just tell you right there. But let's talk about that, because I do want to see what you think. And now that you've had more time to think about it even, can it be any number? A, B, and C. Let me move over here. I have it written down on paper here. They could all be 1, says Megan. Well, that's very true. If A, B, and C all equal 1, then it's 1 times 1 plus 1 equals 1 plus 1 times 1. So this would be 2 equals 2. That works. That is one of the possibilities. They could all be 1. I think this is the only class that come up with that one. Ava says, if A is 1, then B and C can be anything. Oh, that's a great thought too. So if A equals 1, then B could be any number in infinity, all the way to infinity, and C could be. So let's see if that works. If we have 1 times, and let's just pick a number for B. Let's say B is 11. And C is going to be 7. So this is going to be 1 times 11 plus 7. So that's 18. Over here, we're going to have B plus 1 times 7. 1 times 7, 7. Okay, that checks out also. So right here's an infinite number of solutions, right? Because we can just change B to any infinite number of solutions. We can change C to any infinite number we choose. As long as A is 1, this will be true every time. Because all we're doing is adding B plus C, and multiplying it by 1 does not change anything. Love it. There's 2 good responses right there. Anyone else see something in that we might have missed? Because there's more solutions than that even, but I love it. Right now, every solution we've got, A has to be 1, A has to be 1. Is there any solution where A doesn't have to be 1? I think some of you gave me some solutions where A did not have to be 1. Oh, Jacob. Thank you, my man. I was waiting on someone to say that. If B and C are the same number, he said, A doesn't have to be 1. So let's see. Let's say B is 5 and C is 5. So A, we'll just kind of leave it open right now. A times 5 plus 5, because this is B and this is C, equals B is 5 plus A times C. What do we have? The both sides are the same thing. It has a 5 and it has an A times 5, and they're being added together. It has a 5 and an A times 5, and they're being added together. Make sure it looks like a 5. So it doesn't matter what A is. A could be negative 30. It could be 0. It could be 102. A can be any number. Love it. So right here, we found 3 totally different solutions. If they're all 1, perfect. I guess if they're all any number, they could all be 2s, they could all be 7s, they could all be 5s. So if they're all the same number, it works. If A is 1, then B and C can be any number they want to, and it works. If B and C are the same number, then A can be any number, and it works. Look at all the solutions we found in a very, very short amount of time right there, because you guys did some thinking. You did some thinking. I love it. I did copy, and now you don't have to confess if this is you. I did copy some of the answers that was turned in just so we can look at them together. A lot of them, some of you put a lot of thought into, and you gave some great answers. Some of you put very, very little thought into it. Let's look. This is yes, A, B, and C can all be any number. Well, let's look at that real quick, because we didn't try that. Let's say A is 3, B is 6, and C is, how about negative 2? Those are just any numbers, right? All integers. So if A times B, 3 times 6, plus C, and C is a negative 2, so it's subtracting 2. This is 18 minus 2, so this side will equal 16. On the other side, we have B, which is 6, plus A times C. A is 3, C is negative 2. 3 times negative 2 is negative 6, and if we add that to 6, we get 0. That's not equal. So that tells us right off that A, B, and C cannot be any number. Now, this one I found interesting. This said A, B, and C can be any number, and then gave examples. Let me write down one of these examples. So the second example says 59 plus 4 equals 9 plus 54. Well, that's interesting. So you're saying if this is A and this is B and this is C, this is B, A, and C. But here's the problem. If A is 5, so this says A is 5, B is 9, and C is 4. That's not how AB works. We don't just write the 5 and write the 9. You have to multiply those. That should be 45, not 59. You count it like it was 59. You count that like it was 54, but it's actually 5 times 4. That's 20. So this is 49 equals 29, which is not true. So this doesn't mean write the A and then write the B and call it 59. Write the A and write the C and call it 54. That's not what that means. When you see AB, that means you have to multiply A times B. When you see AC, that means you have to multiply A times C. So that one, we still had our summer brains on, right? Because that's not how AB works. This one had a lot of thinking into it. A, B, and C cannot just be random numbers. I checked by plugging in 5, 2, and 4, which is a great way to test something. If you have a theory, plug in just some numbers and see what happens. So they got 14 equals 22, which is not true. So it couldn't just be any numbers. So I think that A has to be 1. So when A is 1, B and C can be any number. And we came up with that solution here talking. So it could be 3 and 4 or 15 and 7. Doesn't matter as long as A is 1. Very nice. Someone did some good thinking there. No, they have to be specific numbers. So A can and has to be a specific number. Same for B and C. But I wasn't sure what numbers. But at least you got to the point that no, it can't be any numbers. It wouldn't work with any numbers. So you got a good start on that. Let's see. If A is any number where B and C are the same number, there. Oh, that's another one we talked about. If B equals C, it doesn't matter. So they said we could say 28, and then B and C are both 67. So 28 times 67 plus 67 equals 67 plus 67 times 28. Perfect. Absolutely. Also, if A is 1 or negative 1. See, we didn't even really talk about negative 1. This equation will be true regardless of what B and C is. If A is 1, 6, and 13, it's going to be 19 on either side. That's true. This says A and B, C have to be specific numbers like A equals 1, B equals 10, C equals 6. But see, that was one of those solutions we talked about. If A is 1, and there it is. If A is always 1 or negative 1, B and C can be any numbers. And this person worked through a lot of examples just to test it. Now notice A was 1, and it worked. 6 equals 6, 2 equals 2, which we figured out anytime A is 1. Here's another one where A is 1 down here, and 3 equals 3. So they said they can't be any number, but as long as A is 1, it works. See, here they tried A was 0, and it came out with 2 is not equal to 4. This one they tried A was 2, and 10 was not equal to 8. So trying different A's, come up with that. B and C have to be the same integer. A possible number for each is 1. Yes, if they're all 1. So good job. You guys did some nice thinking there. You got 10 points just for doing it. So congratulations on that. And I like it's a good start. It's a good start for the semester there. Oh, let's see. I need to be on this page over here. All right. Today, we are going to jump into our Algebra 2 and do our first lessons. See what we're studying today. Third period right here. So in Buzz, hopefully everyone can log into Buzz. So you need to make sure you can log into Buzz before you leave today because you have an assignment. But I want to show you something before we get into our curriculum. If your screen looks like my screen, which means it's a dark gray background, white letters, there are going to be things you can't read because when it does a fraction, you can't read it with a gray background. If it does some kind of equation with an exponent, a lot of times you can't. There's lots of times it messes up displaying numbers with this. So let me show you how to change this. If you log into Buzz and it looks like this, if you click on your name up in the corner, it has a drop-down menu, and the second thing it says is choose theme. So you want to go to your theme and change right here on this drop-down box to light color scheme. That means currently you're on the dark color scheme if you have this look that I have. If you change it to light color scheme, and you can choose whatever color you want for the highlights here. Just make sure it's a light color scheme. Hit save. And now it looks like this. And you will be able to read all of those fractions or equations or whatever numbers were blurry before. They won't be blurry with the light color scheme. That's what we've learned over the years with Buzz. So looking in Buzz, let's look at what lessons are due this week. If I go to the grade screen, which is right here, or up here at the menu, either one gets me to the grade screen. I can see that this week, what's due Sunday, September 1st, is 1.01 and 1.02. It's all about systems of equations, how to solve them algebraically or how to solve them graphically. So that's the lessons we're going to cover today in class. We're going to look at 1.01 and 1.02, and we'll look at the assignments before we leave too. So you can follow along in Buzz. You can just watch me show it on the screen, whatever you do, but you should have some pencil and paper out so you can take some notes because your notes can be used on the test, notes can be used on the assignments, notes can be used on the final exam in December. It's all good. All right, we need to go back to the other activity screen. to get to the lessons. So I showed this on Friday for everyone who's here. If anyone was absent, I'll show it again just to make sure. The academic integrity contract, you have to do that first. Go ahead, Jaden. Go to the academic integrity contract. This is where you click the box, read this, type your name, and then hit yes for both these boxes. And then you will submit that. But don't leave the screen yet. Don't leave the screen yet because there's this button down there. Mine looks gray because I've already hit the button. All right. But there's this button at the bottom of the screen down here that says mark this activity complete. If you don't hit this button, Buzz does not know you turned in that Google form. Google does not talk with Buzz. Buzz does not talk with Google. It won't know you did it. So you have to hit that big button down at the bottom. Then you can go on and look at the lessons. So we're going to look at lesson 1.01 just to start out our curriculum here. Okay, it says Danielle's playing the newest app on her phone, Algebra City Defense. Man, I got to download that one. That sounds fun. In the game, she must help the Mathonauts defend the city against a giant three-headed monster. She can use missiles or ray guns, but she's only got room for 7 of them. 7 total missiles or ray guns, and only 23 batteries to run them. What's she going to do? How is she going to be able to help the Mathonauts save the city? My goodness, that sounds like a math problem to me. So we're going to learn what methods can be used to solve a system of equations and what type of solutions do they find. Let's look at page 2. We can see there's 10 pages for this lesson. It's a longer one. So the remedy for Danielle's situation is use a system of equations, and we can hover over that and it'll give a definition. It's a group of 2 or more equations that have the same variables, like x plus y equals 3 and x minus 1 equals 1, or x minus y equals 1. So a system of equations, 2 or more equations used as constraints or parameters for some situation. For example, after doing more research on the game, Danielle finds that missiles use 5 batteries each, ray guns use 3 batteries each. Now, she had 23 batteries, and she can only hold 7 weapons. So Daniel set up this mathematical problem, set up the system of equations with the variable m to represent the missiles and r to represent the ray guns to find out the maximum she can have to use the maximum amount of batteries and use up her 7 spots. So the first equation, missiles plus ray guns have to equal 7 because there's only 7 that she can hold. She can only hold 7 at a time. And then the second one is 5m because every missile uses 5 batteries. So 5m and 3r because every ray gun takes 3 batteries. So if I use 5 for every missile and 3 for every ray gun, I only have 23 total. So she needs to find out what m and what r would make both of those equations true. That she would use all 7 spaces, so she's carrying the maximum amount of weapons, and she's using all of her batteries. Because if she just got 7 missiles, she wouldn't have enough batteries to run them, because they all take 5. She needs 35 batteries, and she doesn't have 35. So there's 2 variables, 2 equations, m plus r, 2 equations. So how many equations you predict will be necessary for 3 variables? Kind of makes sense. You might need 3 equations for 3 variables. So there's 3 ways you solve this. Either elimination, substitution, or graphing. And we're going to look at those today. So example 1, using elimination to solve this. So let me do this on paper so we can walk through this. X plus y equals 9 and x minus y equals 3. All right, so using this example problem they've given us, and this is not the missiles and ray guns because these are not the right numbers for that, right? So if we have this equation, it's like, okay, so there should be a number for x and a number for y that would make both of these true. And we want to find out how. So with this, we're going to do, this is by elimination. Elimination, put that in our notes. So by elimination, we want to get rid of one of the variables. Well, we're in luck. We don't have to do anything. We already have a plus y and a minus y. So let's just take these two equations and add them together. X plus x, 2x's, y plus negative y, or y minus y, is 0, so that's gone. And 9 plus 3 is 12. So now it's a very, very simple equation. 2 times x equals 12. So if we divide both sides by 2, x equals 6. Okay, we already know one of our equations. So now we can pick either of these equations up above to solve this. Let's take the first one. X, oh, but what's x? X is 6. 6 plus y equals 9. See what we did there? Instead of putting x, we put 6 because we knew x equals 6. So we changed that out. So subtract 6 from both sides. Y equals 3. Well, there's our other answer. Y equals 3. So now x equals 6, y equals 3. We could have used the other one. I said pick either one, so let's do the other one. 6 minus y equals 3. Because that's this equation. Substituting the 6 back in for x. So if we subtract 6 here, negative y equals negative 3. So divide by negative 1, y equals 3. Same answer. We could have picked either equation and got the right answer. So that's how you solve it by elimination. This is the easiest example of elimination because they already allowed us to eliminate it by adding them together. So you add them. 2x plus 0, y equals 12, so 2x equals 12. This will show you all the steps, right? It'll show you all the steps right here. So if you're confused on how to do that, go back and read each one of these steps. Step number 1, identify or create opposite coefficients. Well, they already had opposite coefficients, plus 1y, minus 1y. Let's look at it more. Here's more on systems of equations. So this is another example. Oh, yes, we'll work this one too, because that will give us a better example. That's not necessarily the same. So x plus 2y equals 5, and 5x minus y equals 3. Okay, I've got that written down. Let's look at it here. So here's our two equations. If we add them together, nothing's going to go away. See, here we had a plus y minus y. It went away when we add them together. This doesn't do that. So we need to change something. Well, if we took this negative y, if it was a negative 2y, that'd be perfect, right? Because we have a positive 2y. We need negative 2y. So how can we make that negative 2? Well, let's just take the entire equation and multiply it times 2. If we do both sides, it's fine, right? Like if x equaled 1, then 2x could equal 2, and that's the same. So let's multiply the 2. So then we've got, I'm going to rewrite this first equation. X plus 2y equals 5. And now the second equation, when I multiply by 2, I've got 10x minus 2y equals 6. Multiply it by 2, which gave me a new equation right there. Now, if I add these together, 10x and 1x is 11x. 2y minus 2y, those cancel each other out, equals 5 plus 6. So x equals 1. Because 11x is equals 11. Again, we can choose any equation. We can choose this equation, or we can choose the one we modified. Doesn't matter. Let's go do the first one up here first. 5 times 1 because x equals 1 minus y equals 3. So let's simplify. 5 minus y equals 3. Let's move the 5 over. Minus 5. So negative y equals negative 2. Y equals 2. Well, what if we'd have chose this one that we doubled it? Let's just prove that that's the same. So 10 times 1, because we know x equals 1 is what we found. So 10 minus 1 minus 2y equals 6. So this is 10 minus 2y equals 6. We'll subtract the 10. Got negative 2y equals 6 minus 10 is negative 4. Divided by negative 2, y equals 2. Same solution. Same solution. We had to work a little harder to get something to eliminate because we didn't have a 2y and a negative 2y. We could have, just as a example, we could have, if we wanted to, taken this times negative 5. Because then we would have negative 5x and positive 5x, and we'd have gotten rid of the x instead. Option. That's an option. We could have multiplied by negative 5 instead. We didn't, because it was simpler just to multiply by 2. Multiplying by a negative, it gets all complicated, right? It's certainly not as easy as just multiplying by 2. So we took the path of least resistance. All right, let's get back to our lesson and see what we got next. Let's go to the next page. Real world applications. So the big promotion. You've been working the box office at a movie theater for a year, and you're anxious for a promotion now. So your supervisor asked you to find out how many adults and how many children attended the recent screening of Amazing Algebra 2. I got to put that in my movie list. Amazing Algebra 2. The first one was so great, they made a sequel. So the total number of adult and child tickets sold was 150. That's the information you found. Well, there's 150 people bought tickets. It didn't really show how many of those were adult and how many children. You just know there was 150. And you also know that adult tickets cost $9 and child tickets cost $6. And we brought in $1,155. So somehow there should be a way to solve this. We know the total number of tickets. We know how much each ticket cost and the total amount of money to go see Amazing Algebra 2. So it looks like we'll need some algebra. So we got to identify the variables in writing the first equation. So we're counting the number of adult tickets, A, and the number of child tickets, C, and we sold 150 tickets. So we need to write an equation to demonstrate that. So adult tickets plus child tickets equals 150 tickets. That's what we know. All the adult tickets and child tickets added together, 150. That's awesome. Okay. So now the second equation. If an adult ticket costs $9 and the total earned is represented by 9A, right? So 9A, because $9 for every one adult ticket. And then we would add how much for every child ticket? $6 is what they cost. So 9A plus 6C equals what? Well, we know we brought in $1,155. So 9A plus 6C equals 1155. Submit that. Awesome. All right. So now you have the two equations. And you have a choice. You can either get rid of the A or either get rid of the C. It doesn't matter. It'll work both ways. So let's write this down so we can play with it. Adult tickets plus child tickets was 150. $9 for each adult, $6 for each child, 1155. And again, we can either eliminate the A or eliminate the C. Our choice. So let's see. Let's pick since you can do either one, and they have the other example in our lesson, so you can go back and look at the other way if you would like to. Sharpen that pencil. Let's eliminate the C. Let's just do that. So we have a C and we have a 6C. And we want one of those to go away when we add these equations together, right? When I add them together, one to go away. So if we take this top equation up here and we say, okay, I'm going to take this one and I'm going to multiply it by negative 6. So negative 6 times A. Negative 6A. Negative 6 times C. Negative 6C. And 150 times negative 6. Negative 900. Okay, so we took this equation and we rewrote it down there, multiplying it by negative 6. So let's add these two together now. This is the second equation. That was the first equation rewritten. 9A minus 6A. If we add these together, 9 and negative 6, that's 3 adult tickets. 6C and negative 6C cancel out. Those are gone. That's 0. 3 adult, 1155 minus 900. So we've got 255. So 3 times A equals 255. If we divide by 3, A equals 85. So that's how many adult tickets we sold. A is 85 tickets. So 85 plus C equals 150. That's taking that original equation. We know the adult tickets plus the child tickets was 150 tickets. Subtract 85. C equals 65 tickets. There we go. We know the number of adult tickets now and the number of child tickets. And if we took $9 times this plus $6 times this, that should be $11.55 because that should be true for both. In fact, let's test that just to prove to ourselves. Clear everything. Okay, so $9 times 85. 9 times 85 plus, and I'll put this in parentheses just so we calculate it separately, 65 times $6. 65 times $6. Close the parentheses. That's $3.90. There it is, $11.55. That's exactly what number we used to calculate the total amount of money that came in. It was $11.55. So these are the correct answers for that. So this is how we did it, eliminating the C, where we took that first equation and multiplied it by negative 6. You could go on the other way if you wanted and multiplied by negative 9. So it would get rid of the A, the adult tickets. Either way. Add them. So the way we did it, we came up with 3A equals 255. If we'd have been calculating child tickets instead, we'd had negative 3C equals negative 195. Then we simplify it and solve. We just divided to get 85. Over here, they would have divided and got 65. And then you got to substitute back in to find out the other answer. So we substituted back in. Down here, the AC plus 150. Found that the child ticket was 65. If they went the other way, they'd have been finding the adult tickets. So you tell the supervisor there are 85 adult tickets sold, 65 children tickets sold. She's impressed and gives you a promotion. Great job. If you need more practice, click this real world applications on learn more, and it'll give you another example and another word problem. And then you can try, can I write the equation for this? See if you can write that. And then you can check your answer because they'll tell you right there. Did you find the equations? And then find the solution. All right. So extra stuff hidden in there. So if you want more practice, because you're not sure, it's like, oh, I don't know if I could do that, then you should click here and try another problem. Because it'll tell you if you're right or not. That's the best problems, is when you have the answers that you can check yourself. And don't look at the answer until you do it, but do that. Sometimes in the process of solving a system, the variables disappear. Oh, that's a good example right there. Okay, so let's look at this. Let's work the problem they have there as an example. 2x plus y equals 3, and 4x plus 2y equals 6. All right, so if we want to make one of these variables go away, this time let's do the x, because we've been doing the y. Let's do the x. So we have 2x and 4x. So if we multiply this by -2, now we've got negative 4x minus 2y equals -6. If we add these together, 4x minus 4x is 0, 2y minus 2y is 0, and they equal 0. Huh. We don't know what x or y equals because everything disappeared. Everything disappeared. Well, there's an explanation for that. That means x and y have infinite solutions. There's not just one number. It's any number. Any number. Let's say x equals 2 and y equals 3. Now let's just put it in there and see if it works. 2 times 2. No, that didn't work. Plus 3. Well, I guess it would have to be something that actually works. So y would have to be 1. This will be one solution. If that's 1. No, that's not even right. It has to be -1. -1. 4 minus 1 would be 3. But it would also work in the other one. 4 times 2 plus 2 times -1 would equal 6, because this is 8 and this is -2. But if we chose a different number that was twice as big, what if x equals 4 and y equals -2? -2. So 2 times 4 plus -2 equals 3. No, that's 8. No, equals 6. It's got to double it every time. If we double it. Let's look at their solution on here. Simplify and solve. They get 0 equals 0. This means they have the same y. There's infinitely many solutions. Infinitely many solutions, but there's only certain numbers. It can't be just any number, but there's an infinite number of them. Let's investigate it this way. Let's see what they look like on the graph. 2x plus y equals 3. That is one of them. Okay. I'm going to turn that one off and put this other one. 4x plus 2y equals 6. Oh, look. We changed the color of this one to red. Look, they're the same line. They're the same line. And we found x equals 2 and y equals -1. Oh, it's really zoomed out here. Let's get in here closer. See, 2 -1 is one of the solutions. And 1.5 a 0. 1, 1 is a solution. 0, 3 is a solution. But it's a solution for both of them. There's an infinite number because they are the same line. So when it's the same line, you're going to have an infinite number of solutions. The other thing we can run into, yeah, it's the same solution, is you could have this. We identify this, and when we add these together, see, we multiplied the first equation by -3 this time, and we add those together, the x and y goes away again, but it's not true now because now you get 0 equals 9. See, we got 0 equals 0. That's a true statement. If we would have got 0 equals 9, that means there's no solution Because let's graph this. X plus y equals negative 1. Oh, there we go. X plus y equals negative 1. There's one of the lines. The other line is 3x plus 3y equals 6. See, they're parallel lines. They will never touch. They're two lines that never touch each other. There's no solution. Why is that important? If we have two equations and we want to know what the solution is, it's the point where they cross on a graph. Wherever they cross on a graph, that's the solution that will be true for both equations because that point exists on both graphs. So that's why there's no solution if they're parallel lines, because there's never a place where they touch. See, the more we zoom out, they never touch each other, so there's no solution. If they're the same line, then every point that's on one is on the other. Infinite solutions. So that's the three possibilities we have. We have one solution, we have infinite solutions, we have no solutions. All right, literal equations. When solving equations by substitution, okay, this is going to be another method we're looking at here to solve this. And let's solve one. Let's solve one of the ones we've already done. By substitution. Substitution. This is another way to do it. Before, we were doing it by elimination, which means we was going to get rid of either the x or the y. We eliminated it. Now we're going to do by substitution. So in order to substitute, we need to know what x or y is. So let's take this first equation. X plus 2y equals 5. So what does x equal? Well, let's get x by itself and see. Oh, I don't need an equals there. I'm subtracting 2y from both sides. So x plus 2y minus 2y, that just leaves x. Over here we have a 5 and a minus 2y. So this is minus 2y plus 5. That's what x equals. And we found that using this first equation. So we have to take this and put it in the other equation. Since we used the first one, we have to substitute it in the second one. So 5 times, not x, we're substituting for x. What's x equal? It equals that. Negative 2y plus 5. That's what it equals. Minus y equals 3. So you can see there, I took x out and I substituted in this because that's what it equals. Since x equals that, I can take the x out and put that in, and that doesn't change anything because that's what x equals. Just like if x equaled 3, I could put a 3 in there, but x doesn't equal 3, it equals negative 2y plus 5. All right. Now we need to simplify this equation. 5 times negative 2y is negative 10y. 5 times 5 is 25. Minus y equals 3. Negative 10y minus y. They're on the same side, so we can combine those. And that's 11 y's plus 25 equals 3. Trying to solve for y now. We want to find out what y equals. Minus 25. Negative 11y equals negative 22. Divided by negative 11. Y equals 2, because negative 22 divided by negative 11, y equals 2. Now we want to find out what x equals, so we can go back to either one of these. Let's just use the first one. X plus 2y. So 2 times 2, because y is 2. equals 5. So x plus 4 equals 5. Subtract 4, x equals 1. So that's our solution. We found that by substituting, but let's see, what did we find the first time when we eliminated? When we did it by elimination, we found x equals 1, y equals 2. So you get the exact same answer. There's just two different methods to do it, by elimination or by substitution. Let me show you the third way to do this, because the second lesson is by graphing. So I'm going to take these same two equations and graph them. Okay. So the first equation we just solved was x plus 2y equals 5. So there's the first one. And the second equation that we had was 5x minus y equals 3. Where do they cross? Where the x equals 1 and the y equals 2. Wait a minute. What was our solution? With the x equals 1 and the y equals 2. Make sure you can see that's an x. X equals 1 and y equals 2. X equals 1, y equals 2. When we did it by elimination, x equals 1, y equals 2. 3 different ways we got the same answer, because 1, 2 is also where their graphs cross. Wow, that's pretty nice. All right, so here they want you to solve these for x. Just can we do that? If x plus y equals 1, x equals negative y plus 1. Right? That's rearranging the equation, solving it for that. Solve this for x, solve this for x. So you can try those and then submit. It'll tell you if you're right. Right? Y equals negative x plus 1. Since I didn't answer them all, that's why it's getting mad at me. Okay, here's another one by substitution. So we'll go ahead and watch this video together. It is going to be how long? 2 minutes, 48 seconds. And make sure I'm presenting it in a manner that can be heard, because I bet they're going to have some voice. All right, 2 minutes, 48 seconds. Let's see how they solve this one.
Pick an equation and solve for one of the variables. When you use the elimination method to solve systems of equations, you are able to choose the variable you wanted to eliminate. Here, you will choose the equation and the variable for which you'd like to solve. Since the y variable in the first equation does not have a coefficient, you will find it easiest to isolate, although you're welcome to try any of the others. The first equation is 5x plus y equals 9. To isolate y, subtract 5x from both sides of the equal sign. Now you have the variable y written in terms of x. One variable down, one to go. Substitute the expression for the isolated variable into the other equation. Since you know that y is the same as negative 5x plus 9, you can replace y in the second equation with that expression to obtain a new equation. Now, solve the new equation. Distribute the 3. Combine like terms. Isolate the variable by subtracting the constant from both sides of the equal sign. Simplify. Divide both sides by negative 11. Substitute the value of x into one of the original equations and solve. You may choose either equation, but the second equation is shown here. Substitute 1 for the variable x. Simplify. Isolate the variable by subtracting the constant from both sides of the equal sign. Divide both sides of the equation by 3. You found the value for the second variable, y equals 4. The solution to this system of equations is the point 1, 4. Remember, this means when you substitute x equals 1 and y equals 4 into both equations, you will get a true equation. When this system is graphed, two lines cross at the point 1, 4.
All right. So that was how to solve by substitution. So I did one on paper by substitution. Now we're doing one video we looked at. So generally, it's good to learn multiple ways, right? We know how to do it by elimination and by substitution. And then after you learn them both, you can just pick your favorite. Maybe it's like, I like the substitution better than elimination, or the other way around. Here's more with solving through substitution. So this is another example. We won't watch this one, but it's there for you. A minute 38. You can go back if you still need help with substitution. Go watch this video because they explain it all very well. I don't need to hold your hand to watch that video, but that's there. Check out the other three ways you could have solved this by isolating a different variable. So then they tell you other ways it could have been done after the video. So you usually have choices. Which variable do you want to eliminate or substitute for? So it says explaining complete sentences while solving for the x in the first equation is the simplest variable. Well, in this one, why would the x be the simplest variable to solve for? Because if you divide by 4 to make a y there, then you're going to have a fraction for the x, 1/2. If I try to go for this one, if I divide by 3, I'm going to be dealing with a fraction, -5/3 and -31/3. So pay attention to which one would be easiest. Well, if I divide by 2, this becomes 2 and this becomes 8. I'm still using all integers. I don't have to use fractions. You can solve it with fractions. It's just that takes more thinking, right? So they talk about that in that video, solving substitution, choosing the right variable. Sometimes it doesn't matter, but sometimes it starts giving you fractions and you have to deal with fractions. So let's see if it talks about that. Solving for x in the first equation is simplest because it has a coefficient of 2 by which the other terms in the equation were divisible. Because of this, dealing with fractions was not an issue. All the other variables, you'll end up with fractions. And here's even another example, if you still need more examples on substituting, using the substitution method to solve systems of equations, giving you these two equations. So another example. So they give you plenty of examples. Now let's go back to Danielle and her Mathonauts, where she's got m plus r equals 7 and 5m plus 3r. Let's see, did we solve that one? We did, didn't we? We got 9 and 6. Or 6 and... Yeah. Look at her example. By elimination, because you can just multiply by -3 or -5. Okay, no, we didn't solve that one, did we? She can use 1 missile and 6 ray guns, and that will be maximum 7. And this takes 5, and these take 3 each, so that'll use up all 23 batteries. You could solve it also by substitution and get the same answers. R equals 6, M equals 1. We could graph it and get the same. Look at this. M plus. We'll change it to X and Y for the graph, but X plus Y equals 7. X plus Y equals 7. And the other equation was a 5X plus 3R. 5X plus 3R equals 23. Oh, not R, Y. And look, there's a solution, 1, 6. The X is 1, or the M is 1 missile, and 6 ray guns. Perfect. Using systems of equations to solve that. All right, let's look at page 6. All right, solving a system of equations with 3 variables through elimination. All right, I'm going to write this down so we can do this because this is more complicated. We probably need a better look at this than what we have just reading it on the screen. I think we need to work through it so we can talk through the steps. Okay, so let me write this down. X plus 2y minus z equals -3. 2x minus 2y plus 2z equals 8. And 2x minus y plus 3z equals 9. Okay. And so again, they're going to identify things that create opposite coefficients. So let me switch over to here. So we have 3 equations, and we want to use elimination. Well, those 2's look very different, don't they? 2. So looking at it, the first thing we can see is these first 2 have a 2y and a -2y. Come on, don't bleach out on me. There we go. 2y and a -2y. So we can add those together. What do you think, Ava?
I still can't see the screen.
Oh, it didn't switch, did it? Wait a minute. Okay. I need to wait. Thanks for saying that. When I switched, it didn't switch on the screen. There, I'll make sure it switches on the screen. That's better. Thank you. Thanks for pointing it out. So we have the 3 equations. And the first thing we see is the first 2 equations have a 2y and a -2y. So we can eliminate just by, let's add those 2 together first. So I'll copy them over here. X plus 2y minus z equals -3. 2x minus 2y plus 2z equals 8. So if we add those together, x plus 2x is 3x. 2y minus 2y, there's 0. -z plus 2z is just plus 1z. And -3 plus 8 is 5. So now let's write that over here because we've taken these 2 and added them together. Now we have 3x plus 0y. I'm going to put that in just to keep us straight. 0y, those went away. Plus z equals 5. Okay, right now we don't have anything in common. We can't do this again, 2y and -2y. We have 2x and 3x. We have a 3z and a z. So we need to change one of these equations. Or we could change both of them. Like you could multiply this one by -3 and this one by +2, and these would both become a 6x. But when we have this over here, this looks easier. So let's take the second equation, this one that we just found, and multiply that by -3. -3. So -3 times 3x is -9x. 0, so there's no y's. -3 times z is -3z. -3 times 5 is -15. Now I could have written 0y, but I'm just leaving it out and leaving space. Let's bring this one down just so we can put them together. 2x minus y plus 3z equals 9. Now we can add those together. -9x plus 2x is -7x. No y's minus y. And -3z and +3z cancel each other out. -15 plus 9 is -6. So we've eliminated a lot, but we still have to deal with, we got our y back because we changed equations over there, didn't we? These are different. All right, let's see how they tackled that because I'm going down a rabbit hole. I think I'm making a lot more work than they did. Let's see. So what they did, okay, that's the same step we did. The 3x plus 5 equals there. Then they went back and they did the other 2 equations. No, they used the same equation again, But this time they did it with the third equation. Yeah, I think theirs is going to simplify better. So let's do this. So here's the original problem right here. I don't want to overly confuse people. So we took the first two, right? And we eliminated it to create just this. All right, I don't want to confuse you. So let's scratch this right now. Let's scratch this because they did it a better way. Mine was going to take more steps. So let me put this up. All right. Here's the original equations. We took the first two over here and we eliminated the y to get it to just this equation. 3x plus z equals 5. This was going to take a lot more steps. I like the way they did it better. Now, let's take the first one and the third one. We took the first one and the second one the first time. Now let's take the first one and the third one. So let's go x plus 2y minus z equals -3 and 2x minus y plus 3z. And let's try to eliminate the same variable we eliminated up here. We eliminated the y. So this one, if we multiply this by 2, it's now 4x minus 2y plus 6z equals 18. See what I did? I multiplied everything here by 2. So now let's add these together. Top one and the bottom, because I changed this one to be twice as big. So I've got 5x, no y's, negative z, 6z equals -3, 15. Okay, so now I've got it down to two equations with two variables. I have 3x plus z equals 5 and 5x plus 5z equals 15. That's what we wanted. We wanted to get it down, and I was going to have a lot more steps. We want to get it down to two equations with just two variables. So we could pick any two of these. We just chose the first two. And we could have used the second and third one if we wanted to, but we used the first and third one. But as long as we don't use the exact same two each time, use these two and those two, or the top and bottom and the second and third, whatever, and eliminate the same variable each time. We eliminated the y both times. That's what we wanted to get rid of, was the y. Now we have just a simple two equations. So let's take the first one and multiply it by -5. So we got 5x plus 5z. Now we'll have -15x minus 5z minus 15. Oh, 25. Sorry. Got to do math. Told you I'm going to make mistakes this year. 5 times -5, -25. So when we add these together, 5x minus 15x is -10x. These go away. 15, -25, -10. X equals 1, because -10x equals -10. Now we can go back into either one of these equations with x equals 1. So let's just do this one. 5 times 1 plus 5z equals 15. 5 plus 5z equals 15. Subtract 5. 5z equals 10. Z equals 2. We've got x, we've got z. We can pick any one of these. Any one. Let's just do the middle one. 2 times, what's x? X equals 1 minus 2y plus 2 times, what's z? Z is 2. 2 times 1 minus 2y plus 4 equals 8. 2 plus 4. So this is minus 2y plus 6 equals 8. Getting off the page here. Negative 2y plus 6 equals 8. Combining the 2 and the 4. Subtract 6. Negative 2y equals positive 2. Divide by negative 2. Y equals negative 1. So there we found our solution. X equals 1, y equals negative 1, z equals 2. And we did it by taking 3 variables and changing it to where we only had 2 variables with 2 equations. And then take those 2 equations and solve for both of those. And then we had to substitute back by that. 3 equations is a lot more work than 2 equations, as you can see. When we had 2 equations, we did multiple problems on each page, right? We did like 3 or 4 problems there. This took the whole page by one thing. 3 variables takes a lot more work. We'll see what they come up with. Substitute and solve. Yes, Ava.
Sorry, can I see the last page one more time that we just finished?
Yes. No, that's fine.
Thank you.
In fact, I'm gonna raise up my camera where it shows the whole page at once. We did get the same answers: 1, negative 1, and 2. So, all right. Let's see. Did we get that? Pretty much shows everything at one time, right there. I need to take a picture of that too. Post this in Google Classroom. All right, I'm gonna take a picture of this and put it in Google Classroom as well. If I can get it high enough to get the whole picture. Oh, up there we're talking about the A equals B plus C. Here. I can turn it. I'll turn it sideways for now, and I will rotate it when I get it in Google Classroom to make sure it's right. And I'll take a picture of this side as well. Okay. But there's the one we just did. 3 variables, 3 equations. We have to eliminate it down to 2 with just the same 2 variables. And then we can solve it. Yep. Elijah, you got to do what you got to do, man. That works. If you miss anything, you can catch it on the video if you have to leave before it. So. All right. Solving a system of equations with 3 variables through substitution. We could also do it by substituting. See, they got it down to an x equals and substituted what x equaled into a different equation and into this equation. So they substituted it into both of the other equations. That's how you get it down to just 2 variables and just 2 equations. You pick one that's easy to do. And that's probably the easiest one to do because it already has an x by itself. So if you move everything else to the other side, you'll have an x that you can substitute into both of the other equations. And then once you substitute it in both the other equations, now you've got 2 equations with just 2 variables. 11y minus 7z equals 14 and 5y minus 7z equals 14. And then you can just solve those 2, either by substitution or elimination. Get your answer. Z equals negative 2. Oh, and then they want you to do that. So they want you to go through the steps here to see if you know what you're doing. Enter the appropriate values below. So when you solve for x when y equals 0 and z equals negative 2. So instead of y, we'd put 0. Instead of z, we'd put negative 2. So this would be 3x plus 2 times 0 is 0. Negative 2 would be a positive 2. So when we combine this, 0 plus 2. So what does 3x equal? Subtract 2 from both sides. And x equals 3. We can check that. That's right. So they do have this in here where you can pick. And there's another problem right here. Try this one. When y equals 0 and z equals negative 2. And then after that, there's a third one. So lots of ways to check yourself. And then put your solution. Like, the X, the Y, and the Z. I don't know if that was the right numbers. No, because they're talking about a different problem. But the X, Y, Z. Let's see. Here's an example. Bob, Lane, and Jill are making a bouquet using roses, dahlias, and lilacs. Bob bought 8 flowers. Laney bought 19 flowers. She bought twice as many roses, twice as many dahlias, and 3 times as many lilacs. So you'd have 2R plus 2D plus 3L equals 19. Jill bought 20 flowers. She bought 3 times as many roses. So 3R plus 2D plus 2L equals 20. And so how many of each flower did Bob purchase? So on Bob, all you know is R, D, and L. So the scenario is about 3 people. That means there's 3 equations. So all we know is Bob purchased 8 flowers. So all you know is X, Y, and Z equals 8. That's all you know. But you don't know how many are roses, how many are lilacs, how many are daisies. She bought 2 times as many, 2 times as many, 3 times as many, and Jill bought 3 times as many, 2 times, 2 times, those totals. And that's what you work. So you're solving those 3 equations, and when you're done, check your work. It's right there. Gives the whole solution to get all the way to the bottom of that. Here's our lesson summary. That's the end of this lesson. If you're making notes for the test or for anything, right here should give you a summary of everything we just learned. You can print this off if you want and keep that as your notes. Yep. So there you go. That is the lesson summary. Great place to get notes. And now there's several pages of practice problems. Several pages of practice problems. Solve the equations and then match the answer. Solve that. Which one of these is the answer? Maybe no solution. Maybe you get one of those answers where 0 equals 2. Something that's not true. That would be no solutions. Solution 1. It gives you the solutions up here if you get stuck. If you get stuck, it helps you. There's more down here. 1, 2, 3. You try. And each of those has multiple problems. See, there's 2 problems on the first one. There's 2 problems on the second one. And here's a word problem for your work. Lots of word problems. Lots of practice problems. So if you spend your time working these practice problems, you will have no trouble on the test after you check your work here and know that you're doing it right. Look, 10 problems on this page for you to practice with. 10. So there's lots and lots of practice. All right, we're going to look at the assignment that goes with our first lesson. Let's see what we got. 1, 2, 3, 4, 5 questions, multiple choice. 5 multiple choice questions. This one has 2 equations. 2 equations to solve. This one has 2 equations to solve. This gives you a word problem. It looks like it's just 2 equations. And then the last one is a 3 question. So that's the assignment for this first lesson. 5 multiple choice. 4 of them are 2 equations with 2 variables to solve. The last one is the only big one that has 3. And this one, you don't even have to solve it. They made it easy. You just have to pick which of these 3 equations is correct. Is it the first set of 3 equations? Is it the last set of 3 equations? Which one of those would properly set up the equations for this word problem? So read the word problem and figure out which of those equations would represent that. So that's nice. We don't even have to solve a 3-variable 3 equation, but it's good to know how. All the ones you have to solve are just 2 variables, 2 equations. All right, I'm leaving that. We got one more lesson to look at, but we've almost already done it. It's solving systems of equation graphically, because we've been looking at the graphs. So when you look at a graph, and this doesn't have nearly as many pages. It's coming.
Hello, today we're going to look at graphing system of linear equations. So I have 3 systems here that we're going to go ahead and graph. The first one here You'll notice that the first thing we need to do is put it in slope-intercept form. So I'm going to take my x minus y is equal to 3, and I'm going to put it in slope-intercept form by subtracting the x from both sides. This gives me a negative y is equal to a negative x plus 3. Now I'm going to go ahead and divide everything by this negative 1 so that I get a y is equal to x minus 3. I'm going to graph this. My y-intercept in this case is going to be a negative 3. And the slope is 1 over 1, which means I'm going to go up 1 and over 1. Now I'm going to do the same thing with the second equation. I have 4x plus y is equal to 2. I'm going to go ahead and subtract the 4x from both sides to get y is equal to negative 4x plus 2. I'm going to graph it on the same coordinate plane. So I'm going to go to 2, and then I'm going to go down 4, 2, 3, 4. And over 1. And look at that. We have a perfect point of intersection. Let's go ahead and look at the next one. For the next one, the first equation here, I have to go ahead and divide everything by a 2 so that I can have it in slope-intercept form. And if I do that, I get y is equal to 2x plus 1, which means they're the same exact equation. So when I graph that, I'm going to go to the 1, and then I'm going to go up 2 and over 1. To graph my line. And for this one, since it's the same exact line, we're going to say that there's infinitely many solutions. And for my last one here, I have y is equal to 3x plus 2. I'm going to go to 2, which is my y-intercept, and then I'm going to do the slope, which is up 3 and over 1. So I'm going to go 1, 2, 3, over 1. For the second equation, I have a y-intercept at 1, and the slope is 3 over 1. So I go 1, 2, 3, over 1. And if you notice, these two are parallel. They're right next to each other. And if we go back to the equation, you'll notice that they both have the same slope. So in this case, they're never going to intersect, which means that there is no solution for this one. And this is how we graph linear equations.
All right, so she gave the 3 different solutions you can get with systems of equations. When you have 2 variables and 2 equations, you're either going to have a solution, and that's going to be where they cross when you graph it. Where do they cross when you graph it? That's going to be one solution, right? So like if we switched over to Desmos, these two, if this was a systems of equation, that's the solution because that is the point they have in common. They both cross at 1/6. So that's the solution. The other 2 solutions were if they have the same slope, and she converted these to slope intercept because she was graphing by hand. We can type them in just exactly the same right here. So if we had 3x plus 3y equals 23, let's make it a little bigger so we can tell the difference. See, this is no solution because they don't cross. They don't touch anywhere. If they don't touch, there's no solution. Or it could be the exact same line. Like those are the exact same line. Every point is a solution. Every point on both lines is exactly the same. So there's infinite solutions. So that's what this lesson's talking about. There's more. If you need more solutions of systems of equations, here's another one. Talking about, this is 1 variable equations, 2 variable equations, just how to solve variable. That's a review right there. So systems of equations as 2 variables has an infinite number of solutions, meaning they're the exact same line. This one have 1 solution because there's only 1 place they cross. Let's look at page 3. Using technology. So you have to set up the equations. Peter wants to get the best deal on the internet provider. Mobile Llama charges $25 a month with no fee to set up. Discount Internet only charges $10 a month, but you got to pay $50 to get set up. Which is better? So you can graph the systems of equations. So this is $25 for no setup. $25 a month, so 25x. Y equals 25x. The other one's $10 X each month, but a $50 flat fee. So there's the two equations. So you can graph them both, and you'll see at some point it's cheaper to go to Mobilama. Early on, it's cheaper for discount internet. So let's put them on our graph over here. Y equals 20, Y equals 25X, and Y equals 10X plus 50. Go to zoom out where we can see these. All right. So basically, where are they the same? In between 3 and 4 months. In between 3 and 4 months, it's the same. So if you're only going to have the internet for less than 3 months or less, it's cheaper to go with the green one, where it's $25 a month. If you're going to be on the internet longer than 3 months, then you're better off paying $50 and then just $10 a month. So that's how you figure that out. And then there's another one where he buys baseball cards. And when will one person have more than the other? You solve it. At 6 months, they have exactly the same. I know we're running short on time. This is quick. One of the great ways to apply systems equations when you're faced with an equation like this. Oh, this is a good one. Let me write this down real quick. 5x minus 11 equals negative 2x plus 3. Oh, in fact, let's just put it on a graph instead of writing it down. All right, so what happens when we graph that? We're like, okay, that doesn't make sense. I just made a line up and down. Well, when you have an equation where this equals this, graph them separately. Let's take this and make it its own graph. Y equals that. And make that one y equals that. So we'll graph one here and one here. Now we can see where are they equal. When x is 2, they're equal. So the solution is 2, negative 1. That's how we figure that out. When it gives you something like that, separate them into two equations and graph them. And see, x equals 2 is the solution because that's where they cross. X equals 2. Find the solution to the system equation using graphing. They gave you one graph and 1 points. So negative 3, negative 4 is way down over here. Negative 2, negative 3 is there. Negative 1, 2. So they got a line going this way. They're going to cross right there. And that's the lesson summary. So graphing is real simple. The answer is always where they cross at. If they never cross, there's no solution. If it's the exact same line, it's infinite many solutions because every point they have in common. So we're going to go back and look at the assignment for this one. I know I kind of threw a lot at you to start the year here. All right, solve this system. 2x plus 2y equals negative 6 and 3x minus 2y equals 11 by using graph paper or graphing technology. I recommend you use Desmos. In fact, I'll put this in our Google Classroom as a link at the top of the classwork page. I'll put this material and a link. Graphing website. All right. It is now at the top of our classwork page to find the link for this page. So I want you to graph that and find the solution. It should be easy. Once you graph those two, it should be wherever the point is that they meet, like right here, 2, negative 1 would be the solution. Here's another one. Graph this. What's the solution? Graph that equation, graph that equation. And you can graph it exactly like it is. You can just take that equation, paste it in there, and it makes the graph. Here's one where they give you two equations and say which one of these is the right graph. Well, go paste these two into Desmos and see what it looks like. Then you'll know which of these it is. Here's a word problem, and they want to know what's the solution between the two word problems. When are they going to have the same amount of books? And for this graph, which of these equations matches this graph? That 725 is the solution. That's great. Graph this one and this one. These are, it shows one equation there. But remember, you can go to Desmos and separate them. I'm going to take that one and put it down here. Y equals that one. Y equals that one. Now it graphs them both. I can find what the solution is. Separate those into two different equations. All right. Man, this took a long time. Hopefully we won't take this long every time because that's a lot to throw at you. But it's all about systems of equations, either how to do it by substitution or elimination or by just graphing it and looking. Oh, look, I can see they cross right there. That's the answer. So that's really easy to do with systems of equations. And then we also looked at 3 equations, but all you have to do is set it up in the assignment. You don't have to solve a 3 equation system of equations because that takes a long time. And we're not going to practice enough with that. So you shouldn't have one here. You shouldn't have one on the test at the end of the unit either that you have to solve. You just have to learn how to set it up, set up the 3 equations. So, all right, guys. I think I've filled your minds enough with all kinds of numbers and letters and graphs and everything. We're going to call it quits for the day. All right. Well, if you don't have any questions, have a great week. Next week, Friday is a B day. Next week, we'll meet on Wednesday only because it's Labor Day Monday, no school. So have a great week. We'll see you next week.